Experiment number 13, selective and differential media. So go ahead, please. Look at your plates. We are starting with the first plate, mannitol salt agar. And let me put the plate right here so you can look at the plate, how it appeared before it was inoculated. This is the original plate, mannitol salt, before we inoculated it. The plate was pink. This plate, medium, mannitol salt agar, is both selective and differential. What makes this medium selective? 7.5% salt. It means only halophiles or salt-loving organisms will grow on it. Non-halophiles will not grow on it. This medium is also differential, and the differential ingredient is the sugar mannitol. Okay. So we inoculated 4 bacteria on this: E. coli, Streptococcus mitis, Staphylococcus aureus, and Staphylococcus epidermidis. So let's find out which one of them is halophile, which one of them is not, and which one is fermenter, which one is not. Okay. So here's a plate right here. Oh, can someone pass me the gloves, please? Maria, could you please? Thank you very much. Okay. So, number 11, look at your plates, please. And tell me if you see any growth in number 11, section 11. There shouldn't be any growth because number 11, E. coli, is a non-halophilic bacteria. Correct? Okay. So this is your number 11 right here, E. coli, non-halophile. The other non-halophile is Streptococcus mitis, number 27. This one right here. Do we have any growth there? Nope. Streptococcus mitis. Now the other one that is growing is this one right here. Staphylococcus aureus. Not only that it is growing, it has turned the medium yellow. Why? Because it is mannitol fermenter. It is fermenting the mannitol and making acid. Remember the definition of fermentation from lecture? Fermentation, process in which bacteria produce acid from sugar, right? Some bacteria produce alcohol too, but in this case, bacteria is making acid, and that acid is turning the medium yellow. Okay. The other bacterium, Staphylococcus epidermidis, this one right here. Number 24, Staphylococcus epidermidis, growing, but is it making acid? Nope, no change. So that's how we differentiate between the bacteria on this medium. Differential ingredient, the mannitol, the sugar mannitol. One bacteria ferments, the other one does not ferment. Okay. Both are staph, one pathogenic, the other non-pathogenic. This is the normal flora of our skin, Staphylococcus epidermidis 24. This is Staphylococcus aureus, fermenter. Okay, let's summarize this now. Mannitol salt agar is both selective because of salt. Non-halophile bacteria such as E. coli and Streptococcus mitis, they do not grow. On the other hand, bacteria that are halophile, Staphylococcus aureus and Staphylococcus epidermidis, they do grow, and they can be differentiated on the basis of mannitol fermentation. Staphylococcus aureus ferments mannitol and turns the medium from pink to yellow, and Staphylococcus epidermidis does not ferment.
But the growth, the color is pink.
The growth is actually white. I'm going to go over that. Let's go ahead and fill out the chart in your lab manual now and go over the results now, okay? On page 105, please. The chart. Okay. Staphylococcus aureus, growth present, color of growth yellow, color of medium yellow, fermentation present. Okay. Staphylococcus epidermidis, growth present, color of growth white, color of medium pink or no change, pink, fermentation absent. The other two, NA, not applicable, not applicable, both 11 and 27. Let's do them together, please. Not applicable, throughout. In all columns, please put down not applicable, not applicable, not applicable. Because they are non-halophiles, there was no growth. Okay? Now we move on to the next plate. That was McConkey agar. McConkey agar, who's going to tell me, is it selective or differential? Or both? Very good. It is both selective and differential, McConkey agar. McConkey agar is both selective. Selective ingredient is the dye crystal violet, which is a basic dye used in gram stain, right? But here, we are not, don't confuse it with gram stain, please. Here, when bacteria, they eat, literally eat crystal violet, some of them, they die. Okay. When I was little, okay, I mean really little, 4 or 5 years old, in Pakistan, they didn't give us antibiotics for strep throat. I remember my mom used to take me to, they used to call them dispensaries, government hospitals. When I had strep throat, they used to paste my throat with a purple dye called junction violet. And look at your plate, the McConkey agar plate. What type of growth do you see in section 23? None, right? That is gram-positive bacteria that is not growing there. And Streptococcus pyogenes, strep throat is caused by what? Gram-positive bacteria. So junction violet or crystal violet stops the growth of gram-positive bacteria. So if you have an infection, skin infection, you can just put crystal violet on it, you'll have purple skin. It will look cool, but it will kill. So now I understand why those doctors used to put junction violet in my throat. I was the coolest kid on the block. Everybody really, okay? But it cured the strep throat. Cool. No antibiotic, really. Yeah. But now the pharmaceutical companies want you to buy antibiotics. Yeah. All right. So, selective ingredient, crystal violet, inhibits the growth of gram-positive bacteria. The differential ingredient is lactose, the sugar lactose. Again, some bacteria will ferment lactose and make acid. Some make more acid than others. Those bacteria that make more acid, they will have a pink halo. Look at your plate, please. Okay? Some are making more acid, they have a cloud, pink cloud around it, right? Others don't. Others only have pink growth. Now before I look at the plate that has growth on it, let me show you this plate, please. The plate that was uninoculated. This is the plate that was uninoculated. Right here. Again, we inoculated 4 bacteria: Enterobacter aerogenes, E. coli, Salmonella typhimurium. These 3 are gram-negative, and Staphylococcus aureus, that is gram-positive. Now let's look at the plate that has bacteria on it. Inoculated plate. Here it is. Should I put it on a dark background, Tracy, or is this okay? Looks all right? Yeah, that looks fine. Yeah. That looks all right. Okay. So, the first bacterium, this one, number 11, is pink, beautiful pink with a cloud or halo around it. First of all, the 3 bacteria that are growing on it, they are all gram-negative. The one that is not growing is, excuse me, is gram-positive. So this medium is selective for gram-negative bacteria only. Gram-positive don't grow. This bacterium right here, okay, let's zoom out.
Maybe put the light on it, see if it...
Light, okay. I'm going to zoom out actually. I think I chopped it up a little bit. All right. This is number 20 bacteria, Salmonella typhimurium 20, gram-negative, growth present. It cannot ferment lactose, that's why the growth is gray. I think it's cut off. The growth is gray. The bacteria that ferment lactose, they are pink. Okay. Number 9, the bacteria number 9. Enterobacter aerogenes. Gram-negative again, growth is present, but there's no halo. That indicates it does not make a whole lot of acid. So the growth is pink, but no halo around it. Okay. The other one, right here, number 11. This one right here, gram-negative, growth present, strong lactose fermenter. That's how we tell the difference between E. coli and Enterobacter aerogenes. One has a halo, the other one, no halo. Okay.
What color is the superlative?
Okay, sure. Both are pink. Both
Outside
are.
the medium.
The medium is pink. Medium is pink. Here, medium, no change. Okay.
But in number 20, it changed itself.
20, no change in the median. Yep. No change. Yep. We are going to look at the chart now. Let's fill out the chart. Okay. Yep.
So why does it look kind of yellow compared to?
Just the byproducts. There's no, because they do produce waste, metabolic waste, but not the acid.
So for 23, you want us to put NA for that?
Let's see. You're ahead of me, Stephanie. Okay, let's see. All right. Okay, page 106, please, on top. Growth for E. coli, present. For the first three, E. coli, Enterobacter aerogenes, and Salmonella typhimurium. Growth, present. The last one, Staph aureus, absent. Why? It is gram positive. Color of growth. The first two, they are pink because they are fermenter. The third one, Salmonella typhimurium, what's the color? Gray, non-fermenter. Last one, Staph aureus, not applicable, did not grow. Now, the color of the medium for E. coli, pink, because it has a halo around it, pink. Aerogenes, no change.
Oh, so pink is not green.
Because that's how we tell the difference. This one has a halo. E. coli has a halo. Aerogene has no change. Salmonella typhimurium, no change. Staph aureus, Na. Fermentation for E. coli, positive. Fermentation for aerogenes, positive or present. Salmonella typhimurium, absent. And Staph aureus, not applicable. All right. Let's move on to the next plate, please. Eosin methylene blue. Long explanation. Okay. Yes.
I'm sorry, for the first one, E. coli is present, right?
Yep.
And there was no change in both number 9 and number 20?
Correct. All right. Eosin methylene blue agar is also both selective and differential. Selective ingredients, the two dyes, eosin and methylene blue, it also has bile salts. What do? They do what McConkey does, but not 100%. McConkey, gram-positive, don't grow at all. But look at your plate. Section 23, please. Okay. Open it, that's fine. Remove the tape and open it. Look at it. Pretty, but gross. I'll tell you why. You should see green shimmer, right?
I was gonna ask why it was like so shiny.
Yeah, I'm going to tell you why it's so shiny. Yeah. Number 23, does it have growth? 1, 2, 3. Does it have lots of growth or little growth? Little growth as compared to the other. Because this medium, it says that it partially stops the growth of gram-positive bacteria. and facilitates the growth of gram-negative. So gram-negative, E. coli, number 11, number 9, Enterobacter aerogenes, and number 11, and number 20, Salmonella. All three are growing really good on your plate. It's number 23 that is growing poorly. Okay, so partially stopped gram-positive. Now the gram-negative that are growing on your plate, they can be differentiated on the basis of lactose fermentation, just like McConkey. But here you have two different colors. You have pink and you have green metallic color. On McConkey you had halo, right? But here you have green metallic color. What is that metallic color? Let's first look at uninoculated plate, please. Let me pull this up. Here is your uninoculated ENV. Okay. 4 bacteria we inoculated on this. Can't see the numbers, but we flip it. Still can't see it, no problemo. Let's just go to our this right here. Let me zoom out so I can put my stickies here. The green metallic color that you see here is E. coli. The main purpose of this medium is to detect fecal contamination. Yep. And the indicator of fecal contamination is E. coli. If you suspect your food or water or any other beverage is contaminated with coliform bacteria. Coliform. Take your specimen, put it on this, and look for green metallic sheen. If you see green metallic sheen, you have E. coli. Strong fermenter, just like McConkey. What this acid does, it brings the eosin dye to the surface, and that's what causes this green metallic color. This medium has eosin dye, and the bacteria makes acid that brings the dye to the surface. The other bacterium, number 20, remember from McConkey, is it fermenter or non-fermenter? It is number 20. Again, my little sticky. Number 20 right here. See, gray color, non-lactose fermenter. Gray. Okay. Number 9 here. Enterobacter aerogenes. Pink. Weak fermenter as compared to E. coli. It turns pink. And number 24 right here, which is okay. This one is 23. As compared to the others, you can hardly see any growth. On a scale of maybe 1 to 10, how many numbers would you assign these 3 bacteria? 1 to 10? 8 maybe? How many numbers would you assign this? 3? Okay. Yeah. So poor growth here, abundant growth. Maybe 1. Okay, 1, yeah. 1 to 2 maybe. Yeah. 1 or 2. So yeah, little growth here. Okay. So let's go to the chart. Fill out the chart on page 106, please. Eosin methylene blue. The growth for the first 3 organisms, E. coli, E. aerogenes, and Salmonella typhimurium. present, present, present. The last one you will say present but little or poor in parentheses. Say present, but in parentheses, please put little or small. Little. Number here. Little, poor, scant, whatever word you want to use. Color of growth, E. coli. Green metallic. Green metallic. E. aerogenes, pink. Salmonella typhimurium, gray. Staph aureus, Na. Color of the medium. Now, does anyone have a plate that has green or green metallic halo around the grub? Look at your plate, please tell me. Sometimes it makes so much acid that you have a big halo around it. No? If you have halo, say green, the medium, green metallic. If you don't, say no change. In the past, I had plates that had too much acid. So say no change, that's fine. E. aerogenes, no change. Medium, color of medium, no change. E. aerogenes, no change. Yeah, all three, no change, no change, no change. And then Staph aureus, Na. Fermentation of lactose, E. coli, present. E. aerogenes, present. Salmonella, absent. Staph aureus, not applicable. All right. Our second last plate is phenyl ethyl alcohol. This plate is selective only. It is the opposite of eosin methylene blue plate, a medium. Eosin methylene blue partially stops what? Gram positive. This medium partially stops gram negative. Partially stops gram negative. Please open your plates and look at the growths, the three bacteria. Which one is growing the least? Number 11, good, very good. Because number 11 is E. coli, gram negative. The other two bacteria are gram positive. Here. Okay, I found the other missing one now. Too late. All right. E. coli, little growth, slight growth, scant. Enterococcus faecalis, number 10. Lots of growth, abundant. And number 23. Lots of growth, abundant growth. Oops, can't see it. So phenylethyl alcohol, selective, partially stops gram, negative. Can be used to isolate gram, positive. Okay. Last medium, please do not open it. Okay. All right. Blood agar. Blood agar is differential only, and the differential ingredient in blood is hemoglobin or blood itself. Blood agar without inoculation, and this is the plate which I'm not going to open, but I'm going to show you just like that. Here is section number 29. You should also look at it without opening. Number 29. You can see all the blood is gone, right? This is called beta hemolysis. And that is, this is the bacterium that does that. Streptococcus pyogenes, clear zone around the growth. Beta hemolysis. You just have to put a check mark in your lab manual. Beta hemolysis, clear zone. Beta means bacteria has eaten up the hemoglobin, complete digestion of blood. Do you see that? You can hold it against the light and you will see this clear zone. This is when you have the strep throat, this is what's going on in your throat, and you need antibiotics. And in section 27, you see this partial hemolysis or greenish zone, right there, just like this right here. Partial, you cannot see through the blood. It's kind of hazy, greenish zone. That is called alpha hemolysis, greenish. Streptococcus mitis. Incomplete digestion of hemoglobin. One more time. Now, is it greenish? And then finally, this right here. Nothing going on there. No zone. That's called gamma. Bacteria is not touching the hemoglobin. Okay. Gamma hemolysis is caused by Enterococcus faecalis, no zone. So those are your three types of hemolysis. Beta, complete digestion; alpha, partial hemolysis; and gamma, no hemolysis of hemoglobin. Are there any questions on any of the plates? Yes?
On the mannitol salt agar, you had 29 and 11. Do you have a paper by any chance for the definition that you have?
Later.